Okay, let's talk about moisture in buildings and how we detect it. Well, the truth is most of the time you can see it, that's the case. The most important tools in any surveyor's armoury, apart from his training and experience, are his eyes, often a torch. So a good walk around the building, you're looking for things like salting, stains, high path levels, obvious defects in the fabric that might lead to dampness getting in, you know, roofing details, copings, lead flashings, pointing of course, use of cement on lime, that kind of thing. So these are all defects which the surveyor's taking into account. And when you see one of our surveyors on a job, you'll notice the first thing he does after he's arrived and introduced himself is go outside and have a good old look at that building, look at the outside of it, take into account the topography and the lie of the land, and even look at the adjacent houses, because often on estates in particular you'll get trends that are going in buildings. Now once that's all done and dusted and he's made notes and photographed the defects which he needs to take into consideration, he'll go inside the property, and at this point he may use other tools to help him, and this might include moisture meters. Now moisture meters come in all shapes and sizes, different types, and the most common moisture meter is the electronic moisture meter, and I've got one here to show you. This is the common type which we use. This is made by Fleur, but there are lots of other makes, and really there are many good ones. I've never come across a really bad one, because they're very simple really. I mean, this has got lots of algorithms in that can do lots of other things. It's a combined hygrometer and that, so we can measure the moisture, vapour in the air, etc. But at the moment I want to stick to basic operations. So if we're talking about electronic moisture meters, a surveyor will usually use this in pin mode, and it's easy to see why. Got a couple of pins there, small electrical charge from the battery in here, and dry masonry doesn't conduct electricity. So if we're getting a flow of electrons from one pin to the other, the algorithms in here will pick that up and they'll express it as a moisture level. Not necessarily a moisture content, it depends what you're using it on. If you're using it on timber, then it is a moisture content, and we call that the wood moisture content. So for instance, if we stick this in a piece of pine and we see 20% on the screen, then that's about right. It'll be about 20%, give or take 1 or 2% or so. On the other hand, if we put this on a piece of brickwork or plaster and we get 20, that doesn't mean 20% moisture content, because the meter's not that clever. It doesn't know what you're sticking it in effect. And different materials have different natural moisture levels, different conductivities. There may be various contaminations in there, so salts of various kinds, which may or may not be hygroscopic. So these readings are really a guide when used on that material. That doesn't mean they're not useful, because for example, if we go in a building and we stick the pins in generally, just haphazardly, we'll get an idea of a wall, what its normal moisture level is, and if it's sort of 8 or 9, which is usual, but when we get down near the base of the wall it's 45 or 50, something's changed. Doesn't necessarily mean the wall is damp, but something's changed. It's likely to be damp because normal materials don't conduct electricity. We do get people sometimes saying, oh well, metal foil, and I've done videos before on my blog about that. But a surveyor will know that immediately, because if you stick your meter in a wall and you get 100% absolutely everywhere and it flicks straight up to it like that, it's likely to be foil, you know, so it might happen to you once in your career and then you've learned your lesson, okay? So most properties, we're talking the average building, this is a very useful piece of kit in the hands of a trained surveyor. In the hands of, say, a builder or even a homeowner who's maybe bought one on the internet, then it's a real minefield. You can really get yourself into trouble with electronic moisture meters. Now, one of the things to make sure that we do when we're using a meter is profiling. And what profiling is basically moving the meter up and to the side of wherever you've got a high reading, and that will give you a relative scale of where the problem is. And this profiling is crucial and really useful. And I've been surveying now for 40 years, and I would never go to a property without an electronic moisture meter in my hand. Because the big advantage is that in the space of a minute or two, we can take 10, 20, 30 readings. And so we're getting lots and lots of information. We're not saying that those readings in themselves are quantitatively accurate. They are qualitatively accurate from the point of view that higher here, lower there. That will draw a picture in the surveyor's mind of where the problem might be coming from. Very useful. Now then, there are other meters around, and these include, for example, chemical moisture meters, the speedy meter, this is my own meter which I've had now since the early 90s, and gravimetric methods. These are not a meter as such, but this is another method of identifying moisture in a wall. And the difference between the electronic moisture meter and these meters is basically just the fact that these are quantitative, whereas this is qualitative. Okay? So if, for example, we were to take some plaster or masonry from a damp wall and measure the weight of it and then add it to this vessel along with its carbide reagent, a gas is expressed in direct proportion to the amount of moisture in the sample. That's useful because right here on the end there's a gauge, and if that says 3%, then there's a moisture content of 3% by wet weight in that sample. Now you need to think to yourself, how useful is that information? Well, we'd already used an electronic moisture meter and we found that we were getting a whopping reading. Let's say we were getting, I don't know, 75 on here. It was really, really high for a moisture meter reading on plaster. Now that would immediately tell me that 3% is probably salt contamination. And the reason for that is because there's such a massive difference between the meter reading from here and the real reading here that something else must be happening. So it can be useful in that regard. On the other hand, if we get a higher reading, then it gets a bit more tricky. Because when we're getting readings of 6%, 7%, 8%, those are high enough readings that a meter is going to be, again, up in the 50s and above. So what's really happening? How much of this reading is now due to salts and how much of it is due to real damp? The truth is we don't know. So what you can do is you can then enter the next phase of measurement. I must say though, before I go any further, one of the problems of the chemical meter, and the reason why I actually never use mine, you can see I've got a manual scale on this old meter. The reason is I've never renewed it. I've never bought a brand new one which would be identical to this but would have a digital measure. And the reason for that is because I hardly ever use it. Because it takes about 12 minutes to measure one sample in this meter, and during that time I'm dealing with this highly inflammable material with the gas coming out of here when I've finished each sample, which is explosive. It's acetylene gas. It's not very pleasant. So to do a profile which might be, you know, similar to what I mentioned with the meter, which might take, electronic moisture meter might take a minute or two to get a decent profile, with this half a day by the time you finish faffing about. So people who use these tend not to carry out profiling. They tend to take one or two readings and they're just looking for whether it's low or high. Well, if it's low or high, you might as well just use electronic one. Now, I said that we can go a step further to find out why the reading's there and to decide how much of it is due to salts and how much of it is due to capillary moisture, or what we call free water. In other words, water that's in the wall that shouldn't be there. It's come from somewhere, it might have risen up the wall, it might have penetrated through the wall, it could be condensate that's collected on the surface and absorbed into the wall, and it could be due to water vapour being greedily sucked in by the salts that are there. We call that hygroscopic moisture. There's always some hygroscopic moisture in everything. You know, even the plaster in my office, if I were to take a sample, measure it, it'll have a hygroscopic moisture content of perhaps 1% or so. But when we're dealing, say, with an old building which has been wet for a long time, there's been a cycle of wetting and evaporation that's been happening. It's not gallons of water, it might be just a tiny amount of moisture, but it's evaporating every day, and that builds up a lot of minerals, a lot of salts. If they're hygroscopic, say nitrates, chlorides, ammonium sulfates, ammonium nitrates from chimneys, this kind of thing, then they are aggressively hygroscopic. And like sodium chloride, you know, table salt, if you put it in a humid environment, it becomes sort of claggy and it won't flow. If you go in a chip shop, you'll often find there's peppercorns or rice in the salt cellar. And it's to try to keep it flowing because it's constantly trying to get wet. You know, it's sucking in moisture. And if you've got that kind of salt build-up in a wall, then when you use a moisture meter, or indeed when you use a chemical moisture meter or an electronic one, you'll find that you're getting high readings, but you don't know if there's still a problem. It may be residual moisture due to the salts. It's important to know the difference, because if salts are present at depth in a wall, then in truth it's never going to be totally dry again. It's not the material it was when it was built. It may be 100 years old, and when it was built in lime mortar, you know, and new sandstone, whatever, it did have nitrates and chlorides in, but at tiny levels. These salts are there in tap water anyway. I mean, where do we get our water? We get it from the ground. So obviously it's going to have these salts in it anyway, but they're there at trace amounts. You can hardly detect them. The rising damp cycle, or continuous dampness, say in a chimney, will build up these salts. And of course inside a chimney you've got the added burden of a lot more salt produced by combustion of fuels, coal and wood, etc. Now they're aggressively hygroscopic as well. So we can have a situation where we've identified the cause of the damp in the first instance. In other words, we've lowered the path level, we may have repaired the drains, we may have identified that something was bridged with external render, we've repaired the leaky flashings on the chimney, but we're left with this persistent damp which just seems to perpetuate itself. And often what will happen is the client will say to me, it only appears when it rains. So they become convinced that what's happening is rainwater's getting in or soaking up the wall. And that's not the case. What's usually happening in that event is that you have done the repairs properly. You can leave the poor roofer alone. You know, he's done his flashings and they are working, but the wall is full of hygroscopic salt. And every time humidity is high, for instance when it's raining, those salts become dilated. They're very happy and they absorb a lot of water vapour, to the extent that you can get damp patches that just appear, and often if you rub your thumb on them they'll be a bit greasy. Now gravimetric testing is the only method that we can use practically on site to separate that out and find out what's really happening. And in that way it's a fantastic device for us to use, and it's why in Bricktime we spent the money and time to set up our own damp diagnosis laboratory, because the equipment's a little bit expensive and it takes time to do it, so you need to be a bit passionate, but that suits us. We like what we do. So with some help from some of our friends, Graham Coleman in particular, we set up our laboratory some years ago, and we've had great fun with it, and we've been able to serve clients better as a result of having this. So I'll just explain the procedure for you if that's all right. So we've been along to our building. We're not really sure whether this dampness we're getting at the base of the wall has dried out. It might just be salts that are causing our meter to run amok, so we'll do a gravimetric profile. And what we do there is we use a document called Building Research Establishment Digest 245. Now 245 is a document issued for guidance, and its title is Rising Damp in Walls, Diagnosis and Treatment. If we turn to the back, there's an appendix in there, and that describes the sampling method and that should be used for gravimetric testing, and that's exactly what we've got here, and I can show you now. So we'll go along to the property. We've found a wall suitable for testing, and we're going to take a profile. Now that will involve drilling a series of holes through the face of the wall at low level. The first one as close to the floor wall junction as possible, and that's important because that basically is your datum of your worst datum. You know, that's the bit you'd expect with rising damp to be dampest. It's not always the case with different structures, but that's what we do. And then progressively up the wall, and the number of drillings will depend on the height of the profile. If damp's, you know, apparent all the way up, we'll go all the way up, but usually it might be up to around 1500 millimeters, maybe 2 meters or so, and we'll take between 6 and 12 samples. They have to be taken with a low speed drill. We don't want to burn them up with a sort of whizzy little do-it-yourselfers drill with a high speed small diameter bit. If possible, you can even scrape out bits of mortar and plaster without damaging them. We put them in airtight bottles. They're labelled. We photograph it, of course, and normally we'll take an electronic profile as well at the time for comparison purposes. Once we've done that, we'll bring those back to the office. When we get back to the office, they're carefully weighed out. All right, so we've got a balance here which will measure down to 1/1000th of a gram. We've got a set of calibration weights. It's self-calibrating anyway, it's got its own calibration system, but nevertheless it's nice sometimes to put a 5 or a 2 or a 3 gram weight on it and see that it measures that. So we do that regularly. We then measure each one and we take a note of it. So once we've done that, we've got a weight of the sample from site. Now you know that sample includes its moisture. And that moisture may be free water, capillary water that's been drawn in or soaked into the wall. And it could also be water that's been absorbed by these hungry hygroscopic salts. Now we're going to find out how much the proportion is for each. So what we'll do is if we'll put them in the first vessel, those samples are in here, and just under here there's a saturated solution of lab salt, sodium chloride. And what that does is it maintains a relative humidity inside this dome of 75%. It will fluctuate slightly with temperature, but the salt's buffering it all the time, so it's always trying to come back to 75% relative humidity. Now, those samples will sit there usually about a week or so. That's what I prefer to do. And over the week, they may lose weight or they may gain weight. Okay, they could stay the same, of course, but let's keep it simple. So they gain weight or they lose weight. We need to know what that weight is, and that will give us a lot of information and tell us what's happening. So when we take that out, we will measure it again, make a note of it. So now we've got what we call the 75% weight of the sample. The next stage is we'll take those same samples and carefully transfer them into the company's lab oven. So we've got a precision oven in here which will control the temperature, because if we don't want to bake them too hot, because that will drive out chemically bonded water from the gypsum or lime or whatever's in there. Although with lime you need about 900 degrees, so we're not going to get that. So basically we'll leave them overnight. What that does is drive out some more moisture, the hygroscopic moisture. So now we've got those three weights, we're able to calculate and find out what the different percentages are. If our sample loses weight in here, that's a good indication of capillary water, in other words free water, because at a relative humidity of 75%, when you think about it, the salts that are in that, if there are any, are not going to let go of their moisture. They're very happy in a moisture, in a relative humidity of 75%, so they're going to keep that moisture close. But the moisture that's there not due to salts, the free water, that's going to evaporate off into the atmosphere. So that's identified for us that there's free water in the sample. But how much of it was hygroscopic water? Well, of course, when we put it in the oven, we drive that off. So we can see that the reduction in weight there is the hygroscopic moisture content. So typically what we'll have at the end of the day is three figures. We'll have the total moisture content, which is actually roughly the same as you'd get with this chemical meter. You'll get the total moisture content, everything chucked in. This measures it as wet weight, whereas that measures it as dry weight, so there's a tiny difference. But now we know how much of that is unwelcome water that's still rising or penetrating or condensing on the wall, and we know how much of it is hygroscopic moisture. Now if the hygroscopic moisture is say 1 or 1%, 1.5% or something, well that's the hygroscopic moisture of many old materials, it's quite natural. But it's not unusual on walls affected by rising damp to get hygroscopic moisture contents in the salt band in particular at 6 or 8%. And on chimneys, much higher, over 10% moisture content can be attributable to the action of the salts. And regardless of your remedial operation, you cannot practically or economically remove those salts. If you're dealing with, I don't know, Buckingham Palace or something, then you might want to pay for some various methods of continuous washing and poultice work to remove salts. But if we're talking about, my house or somebody else's house, I just want a dry surface for decoration. And how we approach the salt issue then is to ensure that the materials that we replace the contaminated plaster with are salt resistant or are insulated in some way from the salty background. So I hope this has helped just give you some information about the benefits and disadvantages of different types of meter. And to be fair, they all have a place, and that's why I own them all. I would say the meter of choice, if I only had one and I were called out to do a survey, would have to be the electronic moisture meter, because it does give me a vast amount of information. I can use it all day long and find loads of profiles, and as an experienced and qualified guy, as my surveyors are, that gives us a lot of information. And in truth, we often find that used properly, if you've identified a rising damp problem, using an electronic moisture meter and your survey, of course, all your visual inspection, So you've checked for other causes, bridging, all the rest of it, and you're left with a rising damp profile, then usually your gravimetric will just confirm that. The gravimetric operation will confirm your findings. It's very rare that it doesn't. But the advantage of it is it's clinical, it's scientific, and it's very difficult for anyone to argue with, you know. We've got the backing of building research establishment. So this is a service we offer, but it's not a service that I would recommend people pay lots for regularly. It's something in the armoury to use when required, and in those circumstances we'll tell clients when we think it's sensible to go a bit further. And in fact, on pre-purchase surveys now, where obviously we can't start drilling holes in walls when you're surveying for a buyer, because literally it's only one profile, remember. Moisture meter, you can do a profile on every wall. Nobody's going to let you drill a profile on every wall in the house or wherever to check for rising damp using this method or this method. So we'll use electronic moisture meters on a pre-purchase, but we'll always offer the buyer the opportunity to step up to these methods later before carrying out work. And that's, you know, that's a service. Not many people take us up on it, but it's available for you and we're happy to do it. I hope this has been helpful for you. Thank you.